This number e, let's see, 2 to the power of x, well, y equals 2 to the power of x. The gradient function, the graph of the gradient function looks like that. 3 to the power of x is a bit more, 2 to the power of x is a bit less, and so somewhere in the middle you have something that's exactly equal to it.
Yeah.
And that number is e. It's in between 2 and 3, and it turns out it's this roughly 2.71828. It's a bit like pi.
Yeah.
Number goes on forever. It's a very special number. It is its own derivative.
Okay.
And so, let me just see this for a second. So, if you have y equals, oh, they already have it written down for me. Great. Y equals e to the x. dy dx is also e to the x. Okay, any idea about these ones? The derivative of e to the 4x.
So that'd be 3e.
How'd you get that?
Wouldn't you differentiate it, it says. So you'd minus 1 and then times it by 3.
The derivative of e to the x is e to the x. It's a very special number. What do you think derivative of e to the 4x is?
E to the 4.
Well, e to the 4x, because it doesn't change. A little trick is, what is the derivative of 4x?
4.
And so you multiply it by 4. So that's a thing called the chain rule. They just give you this formula, but that's where it comes from. So e to the x, the derivative is e to the x. E to the 4x, the derivative is e to the 4x times 4, because that is the derivative of the function inside the function.
Okay.
Oops. And so that, come on, man. That simplifies down to 4e to the 4x.
Okay.
So let's try part B.
Okay. Should be minus a half e to the power of minus a half x.
Great. Great. And C.
Well, about 6e to the power of 2x.
That's great. 6e2x minus. Good. Alright, sketch these graphs.
Okay.
Oh, even I don't know. I'm thinking you would just stick it in graphical calculator, but let me think. So e to the 2x looks something, no, sorry, that's e to the x. Y equals e to the x. So what would y equals e to the 2x look like?
Would it be lower?
I don't know. I think it might be a bit like you'd half all the x coordinates. It's a stretch. X direction scale factor 2. So I think it'd be kind of like that.
Okay.
Okay, how about B? Or let's say, what would be e to the minus x?
It'd be like the red line on the first one, just going the other way.
Yep. And so 10 e to the minus x?
Would it be going to the, from the right to the left, but it'll be a lot steeper, the graph, as soon as it goes across the y-axis?
Okay, it's kind of hard to represent that.
Yeah.
So that's y equals 10 e to the minus x. And then how about this one? let's see. So 3 plus 4e to the half x. So we have y equals e to the x.
Yeah.
What would it look like? Y equals, so we'll just change one thing at a time. E to the half x.
It would be less steeper than e to the x.
Yeah, that's gonna stretch x direction scale factor 2. So multiply all the x by 2. Kind of like that.
Yep.
Okay. Then y equals 4e to the half x. What's going to happen there?
It would become 2e to the half x.
You're differentiating it.
Okay.
I'm guessing it's a bit. Come on, man. I'm guessing it's kind of like that.
Okay.
And then with the plus 3. So if you add 3, what's that going to do?
Is that going to make it higher on the y-axis?
Correct. That'll go 3 up from the previous one. So it's just that previous one, except 3 up. What is the y-intercept for all of these except the last one?
Y-intercept 1.
Correct. And so for the last one?
It's 3.
It's 3 higher than 1.
4.
Yep. That's it. Hopefully that's what it looks like. Nope. I messed up. This one was a stretch y direction scale factor 4. So its y-intercept was 1. Then 4e to the half x will be there at 4. And so then that other one would be at 7.
Okay.
Yes. I messed up. Okay. Alright. Bunch of malarkey. Let's see. Differentiate these. Alright, let's try it. Any idea about this?
Okay.
Can you hear me?
Except.
Can you hear me? Hiya, Adam. Hiya, Adam. Hiya, Adam. Hiya, Adam.
Hi.
Hey, was it just the internet or
So
something?
would you... Yeah, probably. So would you simplify it to 8x squared to minus e to the power of minus 6x?
You would think so. I believe it would be e to the minus 1, because that's also on the bottom.
Okay.
To the minus... No, same thing. E
Okay.
to the minus 6x. Yeah.
Okay.
Okay, and differentiate.
So you'd get ax for the first one.
No. Power times coefficient.
Oh, I thought you took away the minus 1 from the power first.
Other way around.
So it'd be 16x.
Yeah.
And then it'll be minus 6e to the power of minus 6x.
Minus 6x. And minus?
Positive, so plus.
Yeah. Okay, B.
Okay. So would you multiply it to e to the minus x by everything in the bracket first?
Yeah.
Would that give you 6e minus 6 to the power of minus 6x minus 6e
Hold
to
on.
the power of minus x?
There's no 6.
But you multiply 2 and 4, don't you?
Yep.
Which gives you 6. Well, no, sorry, 8.
So that's 8. Yeah.
8e to the power of minus 6x.
Hold on. How do you multiply index numbers?
Would be minus 5x squared.
Add the powers.
So it'd be 4x.
Yes.
Minus 6e to the power of minus x.
Let's see. Yes. And then differentiate it.
Okay. So it'd become 32e.
X. Yep.
32e to the power of 4x, is that right?
So that is 32e to the 4x. Yep.
Minus 6, no, plus 6e
Yep.
to the power of minus 2x.
Why 2x?
Because you, after you've minused it and multiplied it to 6x, you have to minus 1 from it.
Then it would be minus x minus 1.
You don't change the coefficient, don't you?
Yeah, you don't change power.
So it'd be minus x.
Yeah. And that's because, like, e is a kind of a special derivative. Okay.
Yeah.
Question 6.
Okay. I got 5 over 2x to the power of minus a half.
Yep.
Minus 20x to the power of minus 3.
Yep.
Plus 80 to the power of minus 2x.
Yeah. Am I crazy, or is 6 easier than 5? They put it back into kind of square root form. So instead of minus a half, they did 1 over root x. Same idea. Yeah, x minus 3. Okay, great. Great, good. Let's see this one. Okay. Any idea how we do part A?
No.
It is, we'll expand this bracket. What do you get?
6x minus 2.
So that's the same as e to the 6x minus 2.
Yep.
You know the way you multiply, you know the way you add powers when they're being multiplied? When you multiply index numbers, you add the powers?
Yeah.
And so that is the same as e to the 6x times e to the minus 2.
Okay.
And so if I swap these two around, that would be e to the minus 2 times e to the 6x. And their one is a times e to the bx. And so what is a, what is b?
A is e to the minus 2.
And
B
b
is e to the 6x.
So just b?
Oh, 6.
That's it. And so, hence or otherwise sketch the graph. Hence or otherwise sketch this graph. How would you sketch the graph?
Okay.
So that's y equals e to the x. What would happen with y equals e to the 6x?
It would be going the same direction, just a lot steeper once it crosses the y-axis.
Yeah. And so that one is y equals... So that's y equals e to the 6x. And so we want y equals e to the minus 2 times e to the 6x. What will that do?
Would that make it go down on the y-axis?
I think it would just be a stretch in the y direction by a scale factor of e to the minus 2. And so that'll be like a bit lower, I think.
Yeah.
Than the black one. Y-intercept?
Minus 1. Wait.
Old intercept is 1. New intercept?
Well, if you're minus 2, then it's minus 1, isn't it?
You times all the y's by e to the minus 2. And so...
G times 1 by e to the minus 2.
Yeah, what do you get?
Oh, e to the minus 2.
Yeah. Am I right? It is 1 over e squared. No, e to the minus 2. Great. E to the minus 2 will be a 6. Okay.
Yeah.
This comes up a lot, that you have to split it into e to the something times e to the something else if they're being added or subtracted.
Okay.
Okay, this is more like it. How do we do this one?
Can you sub a half into equal to the 4x?
Yep.
And that'll give you e to the 2. 2. That'd be right.
Yep.
And then would you just... Wait, so what would you do now?
Well, what is this thing? It says y equals e to the x.
That's the equation of the tangent point, isn't it?
So this one is basically the y coordinate, y1.
Okay.
This is x1. We want the equation of the line. In general, the equation of the line y minus y1 equals m x minus x1.
So we need the x's.
We have x, it's a half, they gave that to us. We only need y1, x1 and m. We have x1, we have y1.
Okay. So with those integers, could you solve for y1, x1 and m? Or not yet?
We have x1 is a half, y1 is e squared. All we need now is m.
So can we sub them all into the equation?
It could. So y minus e squared is equal to m x minus a half. Problem is we don't have m.
Yeah. So can we still multiply m by everything in the bracket?
M is gradient. How do you find gradient?
Y equals mx plus c. Wait, no. y1, y2 minus y1 over x2 minus x1.
Sure, if we were doing GCSE and it was an easy straight line, this is a difficult curved line. F dash of x.
Okay. So working out the derivative of the whole thing.
Yep. Of this.
Okay. So we're just working out mx minus a half.
No.
Or would it be e to the 4x? So it'd be 4e to the power of 4x.
Yep. And so the f dash of x, so the gradient function is 4e to the 4x. M will be specific to our x, which is a half.
Yeah.
So what do you get there?
So you'd sub in a half for x.
Yep.
So it'd be 4e to the power of 2.
Say it again, sorry. 4e to the power of?
2.
Yep. And now equation of the line.
No. Y minus e squared equals 4e squared brackets x minus a half.
That's it. And let me see. And so we'll put it in the form y equals.
Okay. So you'd add e squared to both sides.
Yeah.
Which gives you 5e squared.
No. Plus e squared. What would you get if you expanded the bracket?
4ex squared.
So 4e squared x
and then minus 2 e x squared.
Minus 2 e squared. And simplify.
Okay.
So we can add e squared to e squared, but we can't add e squared x. It's not the same thing.
Okay. So would that become just e squared for the right part?
Minus e squared. Minus 2
Yeah,
plus 1.
minus e squared, yeah. So before e squared x minus e squared.
Yeah. And so in general, y equals 4e squared x minus e squared.
Yep.
There we go. Big picture. So when you have a straight line, gradient is y2 minus y1 over x2 minus x1.
Yep.
That is the gradient. In general, it would be y minus y1 over x minus x1. And if you rearrange that, you get y minus y1 equals, like you times both sides by the denominator.
Yeah.
M times x minus x1. And so for the equation of a line, you just have to find the x coordinate. They usually give you that. A y coordinate.
Yeah.
Oh, hang on. Let me take it even further. The x coordinate we call the f. Sorry, that is x1. Yeah, that's x1. The y coordinate is the f of x1. And
Okay.
the gradient is, let me just make room for myself, y minus the f of x1. So you sub x into the f of x, and the gradient is what you get when you sub x into the f dash of x, the gradient function.
Yeah.
There you go. x1, f of x1, f dash of x1. And you sub all three of those in. Okay, that stuff.
Probably between a tick and a half.
So let's see how we do here. Exponential modeling. Already. Okay. Let's give it a go. We're applying it to the real world. Any idea about A?
No.
So instead of x and y, you have t and p, where t is time, p is the density of the pesticide. 15 days. Time is measured in days.
So you sub 15 into t.
Yep.
So it'd be minus 0.006 times t, or 15.
Yeah.
And then can you multiply them together?
Yeah, I'd calculate it.
Okay.
In fact, I'd put the whole thing in because it's a real world thing.
What, in the graphing calculator?
Just normal one for now, like 160. Shift ln is E. It's under the X button. Minus.
I got 146.8. 228.
Yep. And so that's roughly 146 milligrams per meter squared to 3 sig fig. Okay, so there's 146 milligrams of this pesticide for every square meter after 15 days. Okay, B, interpret the meaning of the value 160.
Is P like the amount pressure? No, 160 is like the amount of pressure given.
It's basically when T is 0, you get 160.
Yeah.
And what's the significance of T being 0?
When there's no time.
Correct. So it's basically in the beginning.
Yeah.
So like the initial density of pesticide is 160. Yeah. So 160 is the initial density of pesticide, something like that.
Yeah.
Okay, how about C?
So it wants the derivative.
Yep.
So would you substitute T in for 15 or keep it as like 0 for T?
Well, T is variable. First it was 15, second it was 0. Now they just want the derivative in general.
So do you need to keep T in the equation?
Yep.
Okay. So I multiplied minus 0.006 by 160.
Yep.
And I got minus 24 over 25.
Great.
Would that be ET?
That would be E. The other bit doesn't change.
To the power of minus 0.006T.
6T, yes. And hold the phone. Hold the phone. Hold the phone. I know. Hang on. Let's keep this even simpler.
Okay.
So minus 24 over 25. That's good. But let me just do something here because they wanted something. I'm sure there's a good reason for it. So it was, I'll do it here, minus 0.006 times 160e to the minus 0.006t. Yeah?
Yeah.
What is 160e to the minus 0.006t equal to from the question?
It's equal to P.
Correct. And so you can replace that with P. And so dP by dt is just minus 0.006p.
Okay.
And that's that. Like K is this value there. K is minus 0.006. Yes, this is a special kind of derivative. Okay. D.
What does it mean by the significance? So like
Of the sign.
like using P instead of minus 0.006 times 160e.
Sign. It's negative. What's the significance of that?
The graph will be going to the left, from right to left.
You're correct. But hold the phone.
Okay.
So this is what the graph would look like, yeah?
Yep.
Oh, come on. This. Okay, all graphy would look like that. However, this is time, and it started from 0, and so it ends up looking like that. And so what's happening to the graph as you move to the right?
It goes down. Time goes down. It goes to 0 when it's used.
Yeah, it's approaching 0.
Yeah.
And so that means that this is exponential decay or exponential decrease.
Okay.
All right, they wrote, no, I can't fit it in. They wrote there. You've got increase and decrease. This was the decrease type. Oh, and then sketch the graph. There we go. What is the y-intercept for our graph?
One.
It was 1.
Or 160e minus 0.006.
160.
Okay.
Because that's a stretch in the y direction.
Okay.
Let's see. And it approaches y equals 0. That's the asymptote. So the derivative, so this is now applying it to the real world. I'll just make sure. Okay, that's what the graph looks like. Fine. Okay. Let's see. After 15 days, sub 15 for t. This is a formula for finding the density of pesticide after a certain amount of time. The significance of 160 is the initial density of pesticide, because that's when time is 0.
Yeah.
dp by dt, you just show the work. You just do the working out and then replace this bit with p. And so that means if you want to find the derivative at any point, so like the rate of decrease, it's just the current amount times minus 0.006, and so that's significantly easier to work with. So let's say, when the density of pesticide, so for part A, the density of pesticide after 15 days was 146. If we wanted at what rate is it decreasing after 15 days, you would just do that 146 times minus 0.006. Nothing fancy. Because the derivative is negative, that means the rate is decreasing, and so it's kind of leveling off. And then you sketch the graph. Okay. Great. Any questions about that one?
No.
So these are a bunch of questions, lots of questions. This is exam question. Okay, let's try this one.
Okay. So I did minus 0.12 times 6, and I got minus 18 over 25.
Minus 18 over 20. So it's real world. So overall value of the car in money.
So you'd find the derivative.
That would be the rate of decrease. So you would just sub 6 into the whole thing. Like just sub the whole thing in.
So you put 6 in for t?
Yeah, but all in one go. So like 29000.
Oh, yeah. Okay, so it would be 20. I got 114,115.8.
Yeah. So I'm going to say 82p.
Okay.
Part B.
So what's the rate?
Yep.
So would you find the derivative first?
Yep.
29,000. So I got minus 3,480 t to the power of minus 0.12 t.
Okay. And when t is 2?
You put it in with, and you substitute t in for 2.
Yeah.
Minus 2,737.46.
Okay. And let me use that technique that was in the previous question. So it was like minus 0.12 times that. That is the same as v, and so it's minus 0.12 v.
Okay.
And so when time is 2, it doesn't get any easier. Let's just see. Was it minus 2737.4?
Yeah.
Okay, great. I accidentally cut out part C. Oops. Part C. Need part C. Okay, that's good. We are good. Find the value. Alright, great. Let's see. Earth pressure is this. How would you do A?
You substitute 4.394 into h.
That's fine. Let's try B.
Okay. So would you work out the derivative of e first?
Yep.
It'd be minus 0.13 e to the power of minus 0.13 h.
Mm-hmm. And they want it in the form Kp, where K is a number.
So it'd be minus 0.13 and then p.
Correct. C.
K is negative.
Therefore.
Therefore,
As K is negative, the density of pesticide is decreasing. There's exponential decay.
okay.
And so this one, K is negative, therefore.
The pressure decreases.
I would just write exponential decay.
Okay.
Yeah, as opposed to exponential decrease. Opposed to exponential increase. And D.
Okay. Would you need to like sub S into the equation?
Yeah, hang on, it's weird though. The atmospheric pressure will change by S% for every kilometer gained in height. Calculate the value of S. I think what I might do for this one, so for every difference in kilometer, so the difference between 1 kilometer in height, I'm going to do the difference between when h is 1 and when h is 0.
Okay.
That's a difference of 1 kilometer.
Yeah.
And as a percent, hang on, I think that's out of the original. And as a percent, you times it by 100.
Yeah.
What's easier, the reason why, instead of the difference between 1 and 2, or 3 and 2, or something like that, a difference of 1 kilometer, anything to the power of 0 is 1.
Yeah.
So that's e to the minus 0.13 minus 1 over 1 times 100. And we don't even need over 1 because that's the same as itself.
Yeah.
All right. I'm trying this.
Okay.
But we'll need a bracket if we don't have it over 1. Minus.
I got minus 12.19.
I trust you.
Okay.
I just want to copy paste. Minus 12.2%. And so that's a change of 12.2%. Oh, minus. I like the minus.
Yep.
Minus 12.2%. Hope so. Hey, that worked.
Yep.
So it's basically, what's the change for 1 kilometer? So I did 1 kilometer minus 0 kilometers. So that's a change in 1. But as a percentage, it would be a change over original times 100.
Yeah.
The original was the 0 one. Right. Let me take a look. Good. Let me see what this looks like. Any idea what A is about?
So it just wants e to the power of 0.02t.
State the value of P naught.
That's p naught. It says it there, p naught e to the 0.02t.
Let's say replace with A. So P equals A. Any idea what that's about? So P equals A e to the 0.02t. What is A for this one?
Would you work out the derivative?
A is when time is 0.
Okay. So you'd substitute 0 for time, which would just give you e to the power of 0, which is 1.
Yeah, so it'd be A times 1, which is A.
Yeah.
So it's the population when time is 0.
So would it just be 1 then?
No. What's the initial population?
18,000.
Yep. And so the way I wrote it, it's 18,000. The way they wrote it, P naught is 18,000.
Okay.
For these, the number in front is the initial one because T is 0 gets rid of the E part. That's the significance. For this one, the initial price of the car, 29,000. For this one, the initial density was 160. Interpret the thing. That's the initial. Yeah, it's always, if it's in this type, in this format, that number in front is the initial one. All right. How would you do part A?
You substitute 1 for t for both of them.
Yeah. That's gonna be fine. I could do the last part of it, but I think I'll just leave it. Okay, let's try B.
Okay. So would it be minus 75 over 2p?
Nope. So how did you get minus 75 over 2?
I multiplied 0.15 by 250.
So it's minus 0.15 times 250 e to the minus 0.15t. Replace something with p.
Replace 250e to the power of minus 0.15t.
Yeah, and so what are you left with?
Minus 0.15p.
Yep. Significance of the sign.
Exponential decrease.
That's fine. I'm going to write decay because it's shorter and quicker.
Yeah.
Minus 0.15p. K is negative, the amount of paracetamol is decreasing. Let's see this. Sure. Let me just go back. One of the ones we skipped. Meaning of 12. Why did he have to do this to me? Okay, question C. Let me improve that question. Is equal to KV. Find the value of K.
150,000 V.
No. dVdt.
9,000 e to the power of 0.060.
Damn, how did you get 9,000?
Multiplied 0.06 by 150,000.
Okay. And so in terms of V?
0.06 V.
That's it? That is it. And so it's
Okay.
that number up there. And that happened for this one as well. That number up there, minus 0.15p. That one happened there, minus 0.13p, and so on. And we got it. So exponential modeling.
Probably between a tick and a half.
Hey, that's great. Okay. How was that for you, Adam?
That was great.
So exponentials is the last chapter for a reason. It's tricky stuff.
Yeah.
Any question? Oh, sorry. So continue this stuff next time.
Yeah.
Any questions in general?
No.
All right. Well, have a nice weekend, Adam. And
You too.
I'll talk to you next time.
You too. Bye.
Cheers. Bye.